Happy Monday, June 1st, boys and girls. I am so excited that we have made it to our last week of math. We are going to do lesson 13 today, and it's all about classifying triangles. Now, triangles can be classified in side lengths and angle measurements. So the side length that a triangle can be is equilateral, isosceles, and scalenes. And we're going to talk about what each triangle looks like. Then we have acute, right, and obtuse for triangles. So let's look at 1A. 1A, as you can see the picture, this is the triangle, and you're probably asking, what are these two lines right here? Those two lines mean that these side lengths are equal. So if you see that in a triangle or in any parallelogram, you will know now that if you see those two dashes, that means that those side lengths are equal. When a triangle has two equal sides, that is called an isosceles. So when a triangle has two equal sides, it's called an isosceles. Now we have to talk about, is it acute, obtuse, or right? As you can see, this is acute, this is obtuse, and what is this side? This is obtuse. So this triangle is actually obtuse. Okay, it's an obtuse isosceles triangle. And hopefully you watched the fun video before you watch this video so you can learn all about these triangles. Let's go to B. B, I see 1, 2, 3 dashes. That means all side lengths are equal. Which one do you think? If all of them are equal, which one do you think it's going to be? Well, some of you see this word equal. So when all the sides are equal in a triangle, it's called an equilateral triangle. That's the best way to remember it by. Then we have to classify it by angle. So acute, right, or obtuse. So look at all these angles, boys and girls. What angles do you see? Do you see acute angles? Do you see right angles? Or do you see obtuse angles? I see acute angles. And actually, in an equilateral triangle, there are only going to be acute angles, boys and girls. Now, the last one is C and D. And we're going to talk about these triangles. As you can see already, what do you notice in this triangle? I see a right angle. So automatically, boys and girls, this is going to be classified as a right angle. But now we have to decide if it's equilateral, which means all sides are equal. So you might want to write this down. All sides are equal. An isosceles, two sides are equal. Not slides. Sides. Let's write it over here. I'll write it. Two sides are equal. And then in a scalene triangle, there are no equal sides. So do you see any dashes in any of the sides? I do not. This side is different from this side. This side is different from this side. And this side is different from this side. So we know if none of the sides equal, it's called a scalene triangle. And we could simply check that with a ruler. You can measure each side to see if all of the side lengths are different. Unfortunately, I do not have a ruler, so I cannot do that at this time, but you can use a piece of paper, you can use your finger, try to use any measurement tool that you have. For D, again, are any of the sides equal? No. So this is a scalene, but this is now is not a right scalene triangle because there is no right angle, so we can cross that out. Is it acute or obtuse? Well, I see 2 acute, but actually, guys, if you see 2 acute, it's the opposite. It's going to be obtuse. There we go. Obtuse. Just like in the isosceles, like I said, there was 2 acute, but really an isosceles is an obtuse angle or an obtuse triangle. So number 1 is your definition and should be your key that you go back to even when studying for the exit ticket. So here we go. Number 2, triangle ABC has 1 line of symmetry, as you guys see right there. What does this tell you about the measures of angle A and angle C? Well, think about it. If I fold the triangle in half right here, what should A and C be like? What does that tell you about the measurements? They're going to be what? Are they going to be different or are they going to be the same? They're going to be the same. So angle A is going to equal angle C because when you fold, if they have a line of symmetry and these 2 angles are opposite from each other, then when I fold it to C, when I fold A to C, they should equal. They should match. So that means that the angles are the same. Now we're going to use that information that I have just told you. So if we have a line of symmetry at another angle, then the opposite angles, A and C, are going to be equal. So let's use that information to do 3A and B. And hold on. My screen is a little blurry. There we go. Triangle DEF has 3 lines of symmetry as shown. How can the lines of symmetry help you figure out which angles are equal? So we have to think about this. So I'm going to take for E. Again, if I make my line of symmetry here, what 2 angles are equal? A and F. And D and F. So angles D and F are equal. Now I'm going to turn my paper this way. If I make a line of symmetry at D, then F and E are also equal because that's a line of symmetry. That means that has to be the same as E. The angle F has to be the same as E. So angle F is the same as angle E. And then if I make a line of symmetry at the angle F, then E and D have to be equal because that means that a line of symmetry, the same image has to happen when we fold it, okay? So we know that angle E and angle D are equal. So what does that mean about all the angles? Do they all equal each other? Yes, they do. D, E, and F equal each other. Now think about what type of triangle is this? If all angles are the same, what does that mean? Hopefully you're thinking that it's acute. It's an acute angle because you're looking at the measurements. So acute, acute, acute. So if I see an acute, look here, what kind of triangle is it? It's an equilateral. So that means this side is equal, this side is equal, and this side is equal. That's why I put the dashes there to show that they are equal. Now for our last problem, it says B. Triangle DEF has a perimeter of 30 centimeters. Label the side lengths. So the whole perimeter is 30, then what should each side have? If there's 30 and I have 3 sides in a triangle, then what should each side be? 30 divided by 3 equals something centimeters, or you could think about it as 3 times what can get you 30? 3 times what can get you 30? 3 times 10. So each side length is 10 centimeters, 10 centimeters, 10 centimeters. And that's how you do 3A and B. So that concludes today's lesson. Today's lesson, I would suggest taking time to remember what type of what type of triangles there are. So isosceles, equilateral, and scalene, and what those definitions are. So remember, equilaterals, all sides are equal. Isosceles, 2 sides are equal. And scalene, all sides are different. Okay? So I would definitely start familiarizing yourself with those vocabulary words. Okay? Well, I hope you have a wonderful Monday. And boys and girls, we only have 3 more lessons left. You can do this. I will see you tomorrow for Tuesday's lesson.